Uh, Good evening, all of you. So today we shall start with
Evening,
some of good evening. Okay, a very good evening. So today we shall start off with some of the basic rules. This is going to be very important because here we are going to discuss the rules. Okay, we are going to discuss the principles involved in the IUPAC nomenclature. Okay, so yesterday, yes, we had discussed elaborately that the IUPAC name is made up of three parts. Yes, prefix. Okay, what is the importance of prefix? Word root. What is word root? Okay, suffix, primary, secondary suffix, and so on. Okay. So now today we shall discuss the rules. Okay. So number one is your longest continuous chain rule. Eh? So number one, just write it down. Number one rule: longest continuous. Okay, longest continuous chain rule. Longest continuous chain rule. Fine. So just give me a minute. Okay. So let us see what does it state. Okay. Longest continuous chain rule. What does it state? So let us see. So in order to select the word root, okay. So word root is derived from the longest and continuous chain of carbon atoms. So it should be longest as well as continuous. Okay, it should be longest as well as the continuous. So let us see some examples. Okay, let us give some examples. For example, we have CH3, we have CH, say we have CH3, fine. We have a branching. So we have CH2, we have CH3, say we have CH3, fine. So does someone please tell me how many carbon atoms are there in the longest continuous chain of carbon atoms? How many carbon
Four.
atoms are there in four? No, four is not the answer. It should be longest
five,
and continuous. Hey, it should be how many are there? Yes, there are
Five.
five carbon atoms in the longest continuous chain of carbon atoms. Very good. Okay, so the longest continuous chain of carbon atoms are these. Hey, it's this. So this is the longest continuous chain of carbon atoms. So see there are five carbon atoms. What is the word root? Now the word root is pent. Now the alkyl groups, okay, which occur as branching, these alkyl groups, these are treated as a substituent. These are treated as a substituent. So what is the word root out here? What is the word root? Longest continuous chain of carbon atom contains
and
five carbon atoms. So it's pent. It's a pent. Okay. Now let us move towards here another. Okay. So 3, 6, okay, fine. So CH3, CH2, CH, so CH3, 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 CH2, CH2, CH3. So I'm just going to rewrite this again. CH3, CH2, CH3, CH2, CH2, CH3. Okay. So these are identical molecules. I have written it two times. Right? Okay. So now just look carefully at these two molecules and let me know how many carbon atoms are there in the longest continuous chain.
So six.
Longest six. Okay, fine. So six means 1, 2, 3, 4, 5, 6. Yes. So I'll just mark it. So if I consider this as the longest chain, how many branches are there? How many branching do you see? How many branching do you see? Branching means from carbon skeleton, how many alkyl groups? For example, here there are two branches, right? So if I consider this as the longest continuous chain of carbon atom, how many branches do we see? We see only one branching from this third carbon atom. We see only one branching. Now there are 6 carbon atoms, but you might argue with me. So why not this then? Don't we consider this as the longest continuous chain of carbon atoms? This also contains 6 carbon atoms. This also contains 6 carbon atoms like this. Okay, so this can be considered as the longest continuous chain of carbon atoms. Right? Okay, or 1, 2, 3, 4, 5, 6. 1, 2, 3. Sorry, not this, not this, not this, not this. I'm so sorry. So this contains only 5, right? So this should be the longest continuous chain of carbon atoms. Look here carefully. So here also there are 6 carbon atoms. The first one also there are 6 carbon atoms. So when a molecule contains two carbon chains of equal length, for example, in this case, the carbon chain, longest continuous carbon chain contains 6 carbon atoms. The longest continuous carbon chain again of the same molecule contains 6 carbon atoms. So which do we consider to be a parent chain? Okay. So now you should note down one point out here. In case there are two longest continuous carbon chain of same length, in case a molecule contains two carbon chains of same length, in case if a molecule contains two carbon chain of same length, okay, if a molecule contains two carbon chains of same length, then the one which carries a greater number of branches So this is going to be important. And then the one which contains greater number of branches is considered to be the parent chain. Got it? So this is an example where there are 6 carbon atoms. Right? So in this way, there are 6 carbon atoms. This way around again, there are 6 carbon atoms. Now the question is, which do we consider this to be a parent chain? If we consider this to be a parent chain, how many branches are there? Just one branching. There एक carbon से एक branching. But if we consider this to be a parent chain, how many branches are there? How many branching do we see? A molecule ka. So we see 1, 2, and 3 branching out here. Right? Okay, here if I consider this to be a parent chain, it contains only one branching. It contains only one branching. Right? So this is not considered to be a parent chain. Rather, this is considered to be a parent chain. Right? So in case a molecule contains two carbon chains of same length, in case a molecule contains two carbon chains of same length, then the one which carries greater number of branches is considered to be the parent chain. So very, very, very important point. It's a very important point. Okay. So is this clear? First rule is clear. Okay. So first,
Yes,
for
sir.
deriving the word root, we select the longest continuous chain of carbon atoms. Fine. And in case a molecule contains two carbon chains of same length, then we should look for the branching end. The one which contains greater number of branches is considered to be the parent chain. Okay, so this is rule number 1. Okay, this is rule number 1, longest continuous chain rule. Fine, I'm rubbing this in now. Now, the point is this. Now, how shall we number? How shall we number? Okay, how shall we number? So let us see. So these are quite simple. These are quite simple. numbering of carbon chain. I think you have done this in your school. Okay, so second point is here numbering of carbon chain. Numbering of carbon chain. Okay. So numbering is done from that end. Numbering is done from that end which gives lower number or highest priority, which gives lowest number to the substituent. So you need to understand some points out here. So I have written just substituents out here. Okay, I have just written the term substituent out here. But the molecule may contain a functional group. It might happen the molecule might contain a double bond, triple bond, substituent, right? So always from which end will you number? You'll number from the end, not at the middle. Eh? So numbering should be done from that end so that the substituent or functional group or the double bond or the triple bond will get the lower number. Eh? Okay. So if all the functional groups double bond are present, what is the order of priority? What is the priority of numbering? Eh? So highest priority means lowest number should be awarded to functional group. Eh? It should be awarded to your functional group. Highest priority, but the lowest number, followed by double bond, followed then after followed by triple bond. First में तुम्हारा substituent है. Okay, so this is the order of priority. If a molecule contains functional group, double bond, or a substituent, then this is the order of priority. Okay. Okay. Say for example, okay, so this is the molecule, right? So now we can easily select the longest continuous chain of carbon atoms. So here 1, 2, 3, 4. Now if I start numbering from this end, so this is the longest continuous chain of carbon atoms. So this is the longest continuous chain of carbon atoms. Is it so? Yes. The longest continuous chain of. If I start numbering from this end, 1, 2, 3, the substituent carbon atom, okay, the carbon atom where the substituent is situated, it will get which number? Tell me. If I start numbering from the right hand side, it will get which number? 1, 2, 3, 4. So the substituent will get number 3. However, if I start numbering from this end, 1, 2, 3, 4, then the substituent, then the carbon atom bearing the substituent will get number 2. So according to this rule, numbering should be done from that end so that the substituent gets the lowest number. So where do we start? Where do I start numbering from? I'll start numbering from the left
Left
hand
side.
side. Left hand side, right? I'll start numbering from here. 1, 2, 3, 4. Now the carbon atoms where the substituents are located, they are known as a locants. Say. Locants means the carbon where the substituents are located. Now, where is the substituent located? Which carbon? Number 2. So how do I name this according to IUPAC? First, I need to name the prefix. Say, prefix means substituent. So 2 position in methyl. So I'll name it as 2-methyl. Fine. Word root, but, carbon-carbon single bond in 2-methyl butane. So this is the IUPAC name. It is the IUPAC name. Okay, so this is the IUPAC name. Got it? Okay.
Yes, sir.
Now, acha. So there are two substituents out here. Eh? There are two substituents out here, methyl and the other is a ethyl. Methyl and ethyl. Okay, so the longest continuous chain of carbon atom contains how many carbon atom? It contains how many carbon atom? Yes, I think this is the longest continuous chain of
So
carbon
6.
atoms. 6. Yes. Now there are two substituents. What are the substituents? The name of the substituents is CH3 means what is the name of this substituent? Methyl.
Methane.
It starts with a
Methyl.
methyl, not methane. This C2H5 is ethyl. Okay, now we must apply a rule out here which is known as the lowest sum rule. Lowest sum rule. Okay, so it's very simple. So if I start numbering from here 1, 2, 3, 4, 5, 6. Fine. So where are the substituents situated? कौन सा position में substituent? Tell me which positions are the substituents situated? Number 2,
2 and 3.
and 3. So what is the sum of locants? 5. It is
5.
situated at number 2 and 3. So 2 plus 3 is 5. If I start numbering from the left hand side. So now if I start numbering from the right hand side, what will be the sum of locants? Tell me. क्या होगा sum of locants? 1, 2,
4 and
3,
5.
4, 5. 4 and 5. So 4 plus 5 is equal to 9.
9.
So numbering should be done from that end, which gives lowest sum of the locants. Got it? It's known as the lowest sum. Numbering should always be done from that end, which gives lowest sum of the locants. So lowest sum कब आ रहा है? When we number from the left hand side. So this is the correct way of numbering. Got it? This is the correct way of numbering, not this. Okay, not this. So always lowest sum rule should be followed. If you have any confusion, just follow lowest sum rule. The one which gives the lowest sum is the correct way of numbering. Now, how do we name the substituents? There are two substituents, methyl and ethyl. Which will you name first? If there are more than one substituent, then they are named in order of alphabetical order. They are named in alphabetical order. Okay. So the which comes first will be named first. Okay, so the number one is your methyl, it starts with M. The other substituent is ethyl, it starts with E. So which comes first in the alphabetical order? M or E? A, B, C, D, E? E.
Ethyl.
So ethyl will be written first. Ethyl will be written first. So yes, tell me guys, what is the name of this substituent, this compound then? It will be 3-ethyl. In number me. Why am I writing ethyl first? Because it comes first in the alphabetical order. 3-ethyl then, yes, tell me.
2 methyl.
2-methyl. Then hexane.
Hexane. Yes, sir.
It will be hexane like this. So in case there are two different substituents, then how are you going to name the substituent? By alphabetical preference. The substituent which comes first in the alphabetical order will be named first. It will be named first. Okay. Now, say the same compound. Now, I'll just write down one more methyl group. Eh? Now, if you follow lowest sum rule, you can either number from this end 1, 2, 3, 4, 2 plus 3, 5. यहाँ से number करोगे भी तो 1, 2, 3, 4. Okay, 2 plus 3, 5. Same. So I can number from either end. Eh? So in any case, this going to get number 2 and 3 like this. Now, if there is more than one substituent, identical substituent, then we use the numerical prefixes di when the substituent is repeated twice. If the substituent occurs thrice, we use the prefix tri, tetra, and so on. So how many methyl groups are there? Two. Okay, so it will be, where are they situated? 2 and 3. So it will be 2 comma 3. It will be 2 comma 3. How many times are they repeated? 2 times 2 comma 3 dimethyl.
Dimethyl.
Then butane. 2 comma 3 dimethyl. So if they occur thrice, 2 trimethyl. If they occur 4 times, tetramethyl, and so on. Got it? So in case of any confusion, we must follow this lowest sum rule. Okay. Now let us see some more examples. Let us see some more examples. So I think you are finding it very easy. Okay, there should be no issue. Just a minute. Okay. Now, from which end will you number? From which end are you going to number? From the left hand side or from the right hand side?
So
So
left
from
hand.
right hand side.
अब लेफ्ट से राइट हैंड साइड से करोगे तो यहाँ पर 3 आएगा, 3 + 4 7. यहाँ से करोगे फिर भी 3 + 4 7. Now in this case, what is actually happening out there? The two substituents occurs at equal distances. A methyl occurs at number 3, ethyl also occurs at number 3. Now here there was no such problem. मिथाइल 2 में था, इथाइल यहाँ से नंबर करोगे तो तुम्हारा फर्स्ट आएगा ये 4. So we start numbering from this end. But यहाँ पर the two substituents they occur at equal distances. Third carbon atom, third carbon atom. Okay. So in this case, so you should note that, okay, if two substituents, occurs at equal distances, if two substituents occurs at equal distances, then numbering the numbering should be done from that end which gives lowest number to the substituent which comes first in alphabetical order. Chalo, write it down. Okay, fine. So, this is a peculiar case. Eh? Now, this substituent again starts with M. This substituent starts with E. So, if two substituents occurs at equal distances, the numbering is to be done from that end, which gives lowest number to the substituent which comes first in the alphabetical order. So, which comes first in the alphabetical order? Ethyl or methyl? Ethyl. So lowest number should be given to ethyl. So obviously we should number from this end. 1, 2, 3, 4, 5, 6. Got it? What would be the IUPAC name, guys? What would be the IUPAC name of this particular compound now? Name it. Now we have a more or less an idea, decent idea. Okay. So what should be the IUPAC name, Chalo? What should be the IUPAC name?
3-ethyl
Very good.
4-methyl
Ethyl will be named first. 3-ethyl, 4-methyl. Then
hexane.
very good, hexane. Chalo, as easy as this. Got it? So this is how we number the substituents. That is how we number the substituents. Okay. Chalo. So these are some set of rules. These are some set of rules. Okay, lowest sum rule, longest continuous chain, and so on. Okay. Now let us see some examples by which we can name the compounds according to your IUPAC system of nomenclature. But before we do this, so I'll just go through the ways of representing a molecule. Now, you can represent an organic molecule in how many ways? Yeah? What are the types of formula? Okay, what are the types of formulae? Okay, so how many types of formula do we know? Yes, we know different ways. There are different ways of representing an organic molecule. There are different ways. Okay, fine. So number one is a graphic formula. Graphic formula, matlab, I'm just going to go quickly through it. Graphic formula. So graphic formula, we show all the bonds. So for example, ethane, we write like this. Or it's known as a structural formula as well. Okay, graphic formula or structural formula. So next is a condensed formula. So condensed formula mein we do not show any lines. We just write down CH3 bond CH3. Bas. So we can write in this way or we can write in this way. For example, propane or butane, we write 4 carbon atoms like this. We show all the bonds, right? Then we represent the bonds like this. Okay, then we write down the hydrogen atoms out here. So this is a butane. This is a butane. Now, condensed formula, how do we write? We write down in this way. CH3 is CH3, CH2, 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 and CH3. Got it? Here we have yet another formula which is known as a bond line formula. Now in bond line formula, okay, we represent the carbon-carbon bond by a line like this, right? So how many carbon atoms are there? I'll take this. How many carbon atoms are there? 1, 2, 3, 4. In between 4 carbon atoms, how many bonds are there? 3. So I'll just show the 3 bonds by in a zigzag manner like this. 1, 2, 3. Okay, so this represents a carbon atom. So how many carbon atoms are there? 1, 2, 3, 4. So this is the bond line formula of butane. So this represents CH3. We have carbon out here, valency 1 and 2. So 2 hydrogens CH2, carbon 2 bonds. So 2 hydrogens CH2, 1 bond. So CH3 out. Got it? So this is a bond line formula. Now, see if I give you this. Okay, now I'm just going to represent this molecule by a bond line formula. Okay, I'm going to represent this molecule by a bond line formula. Achha. So how many carbon atoms are there in the longest chain of carbon atom, longest continuous chain? How many
6.
carbon atoms are? Six. Six carbon atoms means how many bonds are there? One, two, three, four, five. So if there are six carbon atoms, there are five bonds. If there are five carbon atoms, four bonds. If there are 10 carbon atoms, nine bonds. Right? So we have six carbon atoms. So we have five carbon-carbon bonds. Will represent in this way. One, two, three, four, five. Now where does the branching occur from? Second carbon atom. So one methyl branching, CH3. And at the fourth carbon atom, yeah, one methyl branching like this. So this represents here, if I just draw like this, it means I have a CH3 group out here. I have a CH3 group out. Got it? Now say if I have CH2, CH3. Okay, so how many carbon atoms are there in the longest continuous chain? Now, how many carbon atoms are there in the longest continuous chain?
7.
Seven. One,
7.
two, three, four, five, six, seven, eight. Okay, so there are six carbon-carbon bond. One, two, three, four, five, six. So branching. So this is the longest continuous chain. Eh? Don't get confused, right? This is the longest continuous chain. So यहाँ से from this end, the second contains a methyl group. चलो. So one, two, three, four, five में और एक methyl group है. One, two, three, four, five में और एक methyl group है बस. Okay. So we can represent the molecule by a bond line formula. So organic aromatic compound में benzene क्या है? What is this? This is actually the bond line formula of benzene. Now this is the bond line formula. Actually formula of benzene तो ये CH2, we have CH2, we have CH2. We don't write in this way. It will take lot of time, right? We don't write in this way. So we represent the molecule by a bond line formula. Benzene का bond line formula is this. Okay, got it? It's understood?
Yes, sir.
Yes,
Okay,
sir.
fine. Very good. Very good. Oh, very good. So let us see. Let us solve some questions now. Okay. So I'll give you bond line formula as well. Now, okay. Now you guys have become an expert. So now, okay, fine. Okay. So yes, guys, what is the IUP? What do you think is the IUPAC name of this particular compound? Hmm? Give it a try. First, again, you have to select the longest continuous chain of carbon atoms. So how many carbon atoms do you think are there in the longest
6.
continuous chain? 6.
6.
It can go in this way: 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5, 6, whatever. 1, 2, 3, 4. Anyway, तुम्हारा the substituent कहाँ पर आएगा? Number 2 ये और यहाँ पर substituent आएगा. Okay. So I can select the longest continuous chain of carbon atom as these. No, no, not a problem. So numbering कहाँ से करोगे, guys? Where will you start the numbering from? Either end. You will get number 2 यहाँ करने से भी, यहाँ करने से भी. 1, 2, 3, 4, 5. 2 plus 5, 7. यहाँ करने से भी 1, 2, 3, 4, 5. 2 plus 5, 7. So you can number from either end. So I'll just start numbering from here. You can number from either end. 1, 2, 3, 4, 5, 6. Chalo, name it now. What will be the name?
2,5 dimethylhexane.
Very good. Chalo, 2,5 dimethyl hexane. Chalo, good. Very good. Hmm. IUPAC name. Just tell me what will be the IUPAC name. So there seems to be some problem, right? Is there any problem? There seems to be some. Okay, so now let us simplify this. Okay, the condensed formula. So we have a carbon atom like this, which is attached to one hydrogen, right? CH. Now to this carbon, how many methyl groups are attached? Three. So I'll write down CH3, CH3, one more CH3. Got it? So this can be written as CH3 whole 3, CH3 whole 3 means to this carbon, here three methyl groups are attached. Now name it. What will be the name? IUPAC. Now it becomes easy. Yes, tell me. Yes, it will be
2-methyl
2-methyl
propane.
propane.
2-methyl propane. It will be 2-methyl propane like this. Okay. Chalo. Let us just increase the level a little bit. Okay. Okay. So I'll draw here. I'll draw a bigger one. I'll just write it more visibly. So CH3, CH2, CH bracket में C2H5. Again we have CH2. Then again we have CH3 whole 2. Always remember that CH3 can never be in the middle. I can't write CH3 in the middle like this. Why? If I write CH3, what will be the valency of this carbon? 3 already, 4, 5, 6. Is it possible? No. Can I write, if I remove this, then can I write CH3? Is it okay? No. Why? Again, the valency of this carbon would be 3, 4, 5. No. So just remember CH3 can never be in the middle. Okay, CH3 can never be in the middle. Okay, so again, let me just rearrange this a little bit. Okay, fine. This is CH3, fine. This CH2, okay, fine. This is CH. Now C2H5 means to this carbon atom, ethyl group is attached. Bracket में ethyl group means ethyl group is attached to this particular carbon atom, CH. Then we have CH, sorry, it won't be CH2, it will just be CH. Now to this carbon, how many methyl groups are attached? How many methyl groups are attached? Two. CH3 whole 2 means two methyl groups. So I can write the two methyl group out here, one methyl group out here, the other methyl group out here. Bas. I'm just simplifying this. If you follow the slowest thumb rule, I think you should number from the right hand side because it will give you 2 plus 3, 5. If I start numbering from here, it will give you 3 plus 4, 7. So the correct way of numbering is this: 1, 2, 3, 4, 5. So however, what will you name first? Ethyl or methyl? What will you name first?
Ethyl.
Ethyl, because it comes first in the alphabetical order. So what is the IUPAC name?
3
3
ethyl,
ethyl
2 methyl
2 methyl
pentane.
pentane. 3 ethyl 2 methyl pentane. 3 ethyl 2 methyl pentane. Okay, fine.
Yes, sir.
चलो. So I'm just increasing the complexity level. ठीक है, चलो. Now, longest continuous chain of carbon atoms, I think it should be this. So all this represents carbon atom. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 carbon atoms, the longest continuous, or 7, 8. Now, numbering should be done from that end so that the substituent gets lower number. So if I start numbering from this end like this, the substituent is starting from number 3. 1, 2, 3. Number 3 से start हो रहा है. However, if I start numbering from this end 1, 2, the substituent is getting number 2. So always numbering should be done from that end so that the substituent will get a lower number. Okay, so I'll start numbering from here. 1, 2, 3, 4, 5, 6, 7, 8 like this. Not here because if I start numbering from here, I'll get 1, 2, 3, 8. Got it? Now, what are the substituents out here? So there is just one line, means there is just one carbon atom. This means we have a methyl group. This represents a methyl group. Hey, this represents a methyl group. This CH3. CH3. Now tell me, what is the name? What will be the name? Tell me.
2,6 dimethyl
Dimethyl. What?
octane.
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 2,3 dimethyl octane. Okay, now you can name any compound you feel like. Hey. Okay, now you can name any organic molecule. Say okay. So how many carbon atoms are there in the longest continuous chain of carbon atoms? Let us see. Let us count.
6.
1, 2, 3, 4, 5, 6. Or it can be 1, 2, 3, 4, 5, 6 as well. 1, 2, 3, 4, 5, 6. Okay. So if I consider this as the longest chain, how many branches do I see? If I consider this as the longest chain, how many branches do I see?
3.
3.
If I 3, good. If I consider this as the longest chain, how many branches do I see? This
3.
3 again. Equal. So anyone can be considered as the parent chain. So I'll consider this 1, 2, 3, 4, 5, 6. Where will you start the numbering from? If I start numbering from this end, the substituent will get number 3. However, if I start numbering from this end, the substituent will get number 2. So again, the numbering should be done from that end. So the substituent gets the lowest number. Lowest sum rule 1, 2, 3, 4, 5, 6. What is the name of this substituent? What do you have out here? Methyl group.
CH3.
What do you have here? Just one methyl group. How many carbon atoms are there? 1, 2. So this is a ethyl. 2 carbon atom wala alkyl group means ethyl. Got it? Now, which will you
Yes, sir.
name first? Which will you name first?
Ethyl.
Ethyl.
Ethyl. So what is the name?
Ethyl.
4
Ethyl.
4 ethyl.
2, 3
ethyl,
ethyl.
2,
2,
3
3
di
methyl. Dimethyl.
dimethyl, do it, dimethyl hexane. Now you might argue with me. So Dita, it comes first before E. Why have you written E first? Well, considering the alphabetical order, the numerical prefixes such as di, tri are not taken into account. Right? Okay, we don't compare the alphabetical order of D and E. Why? Because di, it was added because there were two methyl groups. Got it? So you don't take into account the alphabetical order of numerical prefixes. Got it? So don't think that D comes before E. So di, no. Numerical prefixes का alphabet तुम लोग consider ही नहीं करोगे. Okay, so this is how we name. So today we have learned the IUPAC nomenclature of some simple systems. Right? These are not complex. These are simple ones. Okay. So tomorrow we will move into more complex things: functional group, double bond, triple bond, and so on. Okay. Okay. So let us keep it till here today. So
Yes, sir.